Welcome to Object-Oriented Programming classes. The prerequisite of this class is data structure and problem solving, fundamentals of programming languages. So in Unit 1, we will discuss about the foundation of OOP. Languages like COBOL, Fortran, C, these all are high-level languages, are commonly known as procedural-oriented programming or POP languages. In POP, the number of functions are written to accomplish a particular task. So there can be several numbers of functions, and it looks like there is a main program, and main program are divided into number of sub functions. So there can be n number of functions. So here the importance is on doing things. So we are more focused on algorithm. So a larger program can divide it into smaller program known as functions. Most of the functions shared global data, and data can flow openly around the system from function to function. So the program is less secure, and it's vulnerable also. It follows top-down approach. In programming design, there are two approaches, bottom to up, and one is another is a top to bottom. So this top-down approach, it followed by these POP languages. The main limitation of this POP is basically as the data are moved from one program to another, freely around the program, one function to another function. Therefore, it is very vulnerable to changes caused by any function in the program. And another, it does not model very well any real life problem. So for these, we need object-oriented programming. In object-oriented programming, the object communicate within themselves, and the objects are basically combination of data and the operations. We can say it ties data more closely to the function that operate on it and allows decomposition of problem into objects. So the main focus of object-oriented programming is on the object and the communication in between the objects. So procedural language and your object-oriented programming language, if you try to compare, you will see in POP, the programming is divided into small parts. These are called functions. And in OOP, it's divided into objects. The importance is mostly focused on the data in case of POP. And it follows a sequence of actions it needs to be done. And in OOP, it mostly focuses on the procedure or the functions because it works as a real objects, real world problem solving. So the approach is the POP follows top-down approach, whereas the OOP programming languages, this object-oriented programming follows bottom-up approach. Access specifier in POP, there is no access specifier, but in OOP, there are access specifier like public, private, or protected, etc. Data movement, freely data can move from one function to another function in POP. In object-oriented programming language, data can move, communicate with each other. It's not data, like it's object. So through the member functions only. The expansion, you can create new data or the function in POP. It's not so easy, but in OOP, it is always easy to create new data or say create new functions. Data access, mostly global data shareable amongst the functions. It's freely available, freely accessible. So data access is very, less secured, data hiding part. Here in OOP, data access is not that much easy because function to function, it can be public, private, protected. There are level of access specifier, and it's highly secured, this OOP programming language. So example of POP like C, VB, Fortran, Pascal, these are the example of POP. And in object-oriented programming language, the examples are like C++, Java, VB.NET, or C#.NET, etc. So we'll discuss about the fundamentals of OOP, like objects, classes, encapsulation, data abstraction, inheritance, polymorphism, dynamic binding, message passing. Initially, we will go through one by one. Then after that, individually, we will discuss more in the consecutive lectures. So objects are basically the fundamental block, building block of any OOP programming. So objects are basically a runtime entity. So the data and the operations means the functions are closely tie up with each other, and they are the real world existing entity. Objects are, so you can say objects are instance of a class. These are the instance of a class. Now, attributes and operation. An object having attributes and they have many different operations. Like, so for example, student object. Student is an object where there's student name, ID, branch, semester. These all are attributes. And the operations are enroll, perform, or display information or results. These all are different operations. So these combiningly we called that this is an object. So there is data, there is functions or operations. Now class is a collection of those objects. So class is a blueprint of an object. So it's a collection of those objects is called a class. Now what is encapsulation? Encapsulation is wrapping up the data and the functions into a single unit, which is called basically known as class. So this is called encapsulation. So you try to encapsulate the data and the functions into a single unit. That is the main objective of encapsulation. So the code and the data, it's a mechanism that associates the code and the data, and it manipulates into a single unit and keeps them safe from the external interface and misuse. So as it is, keep this to intact. So it's always restrict from any kind of misuse, extraneous misuse. So encapsulation means it can encapsulate the class, which is student class, attributes, and having different functions. Now talking about data abstraction refers to the act of representing essential features without including the background details or the explanations. So it's a kind of data abstraction. It's a simplified view of an object where the main interest is on the features, not unnecessary details. So we are not bothered about the unnecessary details, and we always try to hide all those unnecessary details. So again, abstraction refers to the act of representing essential features without including the background details or the explanation. So background detail you need not to incorporate this explanation need not to be there. Now, inheritance is a mechanism to provide the power of reusability and extendability. Like inheritance is a process by which one object can acquire the properties of another object. So it actually acquire the properties of another object. So object A acquire the properties of object B, something like this. So suppose there is a point, is a base class or the parent class, and there is a derived class or a child class called line. So line having, is basically derived from the parent class or the base class called point. So there are n number of points which actually forms one line. Inherits, this is called inheritance. Inheritance is a mechanism of creating new class called the derived class from the existing one that is called the base classes. So inheritance is the most powerful feature of object-oriented programming. And there are two different classes. One is called the superclass, one is called the subclass. The base class is the superclass, the class being inherited from. The class being inherited from. And derived class is a class which is called a subclass, the class that inherits. So these are the two classes for the inheritance. Now, the basic advantage or the benefits of using inheritance is, or the advantages are, one is reuse. The method and the data of the existing class you can reuse. Second is you can extend the existing class by adding new data or new features, methods into it. You can modify the existing class by overloading its methods with your own implementations. You can modify. So we used extend and modify. These are three main advantages of inheritance. Now there are different types of inheritance, like single level inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, hybrid inheritance. Now talking about single inheritance, when a derived class inherits only from one base class is known as a single inheritance. Like there is one-to-one mapping kind of, one is a parent class, one is a child class or derived class. So B is derived from A. This is called single inheritance. In case of multiple inheritance, when a derived class inherits from multiple base classes. So base classes can be multiple, like A, B, there can be multiple number of base classes. From all these base classes, one derived class is the C. So this is called multiple inheritance. Multi-level inheritance, when a derived class inherits from a class that itself inherits from other class. So you are inheriting one class that is inherited by another class. So like there is a base class, you inherit, the child class is the B class B, and B class is a parent class of C. So C is derived from B. So this is called multi-level inheritance. There is hierarchical inheritance when many derived classes inherit from a single base class. So base class is class A, and you have lots of different derived classes from A. This is called hierarchical inheritance. And hybrid inheritance, commonly two or more form of inheritance. This combination is called hybrid inheritance. So multiple inheritance is an example, like class is a sub where public super A and private super B. So you are inheriting public super A and super B, and the class subclass, subclass, class sub. So this is the way of writing for programming language to another programming language. It's different. We will discuss more on this once we will talk about inheritance. Now there are different access specifier, like type 1 access specifier inherit as private. So what is the base class members and what is the derived class member? So private members inaccessible, protected members, private members, public members, private members. So these are the type 1, that is the inherit as private. Now inherit as protected, base class private members, derived class inaccessible. Protected members, public members, protected members. So these are the type 2, that is the inherit as protected. Third one, inherit as public. So private members inaccessible, protected members, public members. So these are the different, inherited access specifier, types of access specifier, which we will discuss more once we use this in programming languages. Now coming to polymorphism, the ability to take more than one form. So that's called the polymorphic in nature. So polymorphism means same thing can exist in more than one forms. Like we know carbon having this property, it's very well-known property, polymorphic in nature. Like polymorphism is a sort of ability to call different functions by just using one type of function call. What is that? Like is a plus symbol. In different cases, it acts as different, forms different. Like in string or say in numeric in between values, they are having different meaning. So it's polymorphic in nature. Now coming to dynamic binding. Dynamic binding is a process of linking the code associated with the procedural call at a runtime. So this procedure call at a runtime, we will talk about more on this in dynamic, the kind of method dispatch or something different other topic. We will discuss more on this. Then comes message passing, the process of invoking an operation on an object. Invoking an operation on an object is called message passing. The response to a message, that corresponding method is executed in the object. So how it looks like There is a student object, there is a faculty object, there is a management object. So performance and results, so these are all message passing. So message passing is basically, is a kind of invoking an operation on the object, what type of operation you are invoking. So that needs to be clear in message passing. Now coming to the relationship, the class is a template, whether it's a blueprint of an object. So object is the instance of a class. So there can be instance objects, the number of instances you can create from a class. Like in class diagram, is a diagram describes the structure of system, shows the system's classes, attributes, operations, that is the methods, and relationship among the classes. Now, there are different types of relationship: association, aggregation, composition, dependencies, generalization, and realization. Now, in association, an association between two classes describes the connection among them. If the association is between two classes, then this is called a binary association. And if more than two classes, this can also happen. So the degree depends. Now, it is represented by a solid line. So employee and the company. So what is association? The employee works for a company. So this is the association. Now, class A and class B, role A, role B. So like company, employee, person. So it's an example of an association. Now, aggregation and composition. Aggregation, it's a shared aggregation. It's a specialized form of association in which a whole is related to its parts. Mostly this is called a hazard heuristic. Hazard. So what is hazard? Three ways of think about aggregation: whole parts, container, contents, and group members. And composition aggregation, it is stronger version of aggregation, and these parts may be the only whole. So the parts usually expected live or dead with the whole. So aggregation, association, and the composition, there are three different forms. Like these are the two examples of aggregation: faculty and the course teaching, and the cells order and the cells order line item. So one is composition, one is aggregation. One you can say is a has a heuristic. So teacher has a course teaching, teaching course, and cells order, it's only one way of writing. So it's a one whole. So cells order having one whole cells order line item. Generalization is deriving a class out of the parent class having some inherited property, some new property of the derived class. In terms of generalization, is the form of inheritance from bottom to up direction. So it's a kind of like a generalization car and trunk. Generalized version is the vehicle. So you can represent by a solid line, and the head pointer will upward direction. So this generalization is basically deriving a class out of a parent class having some inherited property. So it's a one type of inheritance, but here the inheritance is a bottom to a direction. That is the generalization. Now coming to dependencies, dependencies relationship is a weaker form of relationship. Why this is called weaker form? The dependency states that a change in specification of one class may affect another class that uses the first one, but not the vice versa. Means there is a dependent class, there is a reference class. So there is a dependency, and this dependency, one class is affected by the other class, not vice versa. So it's represented by a dashed line. And lastly, realization. Realization is very similar to inheritance. The only difference between them is a class is divided into interface instead of base class. So here there is no base class and derived class, rather it's an interface class and derived class. So any derived class is derived from the interface class. So this is called the realization. Thank you very much.